What if I told you robots are about to take over? Not in some science fiction way, where machines rise up and humanity fights back with laser guns. No, the truth is far more subtle and far more real. The biggest shift in the global workforce isn't happening in boardrooms or on Zoom calls. It's unfolding silently inside factories, warehouses, and labs. And the mastermind behind this revolution? A company you already know. For years, they've been known for making graphics cards, but what they're doing now is far beyond gaming. They're building an empire of intelligent machines capable of thinking, learning, and physically interacting with the world. And they're doing it faster than anyone expected. Why we even need robots. By the end of this decade, the world will be short by at least 50 million workers. That's not a prediction. It's a reality already taking shape. From aging populations in industrialized nations to shifting job trends, there's a massive labor gap growing. Employers are struggling to find people willing or able to do repetitive, physical, or hazardous jobs. And here's the kicker. Companies would gladly pay those missing workers $50,000 a year if they existed. So what's the solution? Enter robots. We're not talking about clunky machines that move boxes back and forth. We're talking about fully autonomous, physically capable, AI-driven systems that can do the work of humans and never ask for a raise. The robot industry is projected to become one of the largest global sectors, rivaling even the automotive and tech industries. And NVIDIA wants to own that future. And they're not alone. Countries like Japan and Germany are racing to fill workforce gaps with automation. Global economies are quietly realigning around the idea that the future worker may not be human at all. Everything around you is already a robot. Think robots are futuristic? Think again. Every car with a lane assist or parking sensor is already a form of robot. The cameras in your phone? Robots in disguise. The infrastructure behind Amazon's delivery system? A symphony of mechanical and algorithmic automation. There are 10 to 20 million factories worldwide, and automation is rapidly invading every one of them. We're not watching the beginning of the robot era. We're already living in it. The only difference now is that the robots are becoming smarter and starting to think. Even your dishwasher runs on logic protocols that qualify as basic machine intelligence. Robotics isn't a trend, it's a creeping inevitability. From smart machines to physical AI, most AI lives in the cloud. It processes data, makes predictions, and writes code. But physical AI? That's a whole new beast. Physical AI is the merger of intelligence and movement. It's what happens when you take the brain of an AI model and give it hands, wheels, cameras, and a mission. But training these robotic minds isn't easy. NVIDIA identified 3 major challenges. Where do you get the massive amount of data needed to train robots? What kind of model architecture allows them to learn physical interactions? And how do you scale that learning across millions of devices? Their answer? A universe. Literally, Omniverse and Cosmos. Building worlds to train robots. Enter Omniverse, NVIDIA's operating system for the real world. Think of it like the Matrix, but for training physical AI. Inside Omniverse, NVIDIA built a tool called Cosmos, a generative AI that can create infinite environments to simulate real-world physics. These aren't just 3D models, they're fully interactive spaces where robots can live, learn, and fail without ever breaking a real object. Why does this matter? Because data is king. And with Cosmos, NVIDIA can create infinite amounts of high-quality, controllable, physics-grounded data for training. They can drop a robot into 1,000 virtual kitchens, let it fail repeatedly while trying to grab a mug, and use every success and failure to make it smarter. This isn't training robots the old-fashioned way. This is wargaming intelligence at scale, and it allows for risk-free iteration. Want to train a robot to sort eggs? Let it break 10,000 digital ones first. Reinforcement learning and the laws of physics. Creating fake worlds isn't enough. Robots need to understand reality. The weight of a box, the slipperiness of a floor, the difference between pushing and pulling. That's where reinforcement learning comes in. AI learns best through trial and error, but in robotics, you need to verify those errors with real-world consequences. NVIDIA figured out the answer. Physics. They created a new physics engine called Newton, designed specifically for robots. It simulates soft bodies, rigid bodies, and even tactile feedback, down to individual motors and sensors. And they didn't do it alone. Newton is the result of a partnership between 3 giants, NVIDIA, DeepMind, and Disney Research. Why Disney? Because they've been simulating physical movement and animations for decades. Blend that with DeepMind's AI research, and NVIDIA's GPU power, and you get something unprecedented, a hyper-realistic, real-time physics engine for robotic training. This is how you train a robot to walk like a human, pick up fragile items, or thread a needle. It's precision engineering meets science fiction, and it's becoming real. Meet Blue, the robot with 2 brains. In one of the more surreal moments of the GTC keynote, NVIDIA introduced Blue, their in-house general-purpose robot. Blue isn't a product you can buy. It's a prototype, a proof of concept, but it's smarter than it looks. Inside Blue are 2 NVIDIA computers, running the Omniverse OS and Newton physics engine in real time. This means Blue can see, react, and adapt instantly. It learns on the fly, gets feedback from every movement, and continuously improves. It's like ChatGPT with arms, and when it makes a mistake, it doesn't cry, it just learns. This is what the future of robotics looks like. Not cold machines, but adaptive, intelligent physical agents who can learn like humans, but faster. Blue may be a cute prototype now, but imagine a factory with 100 Blues, or a hospital, or a military base, open sourcing the robot brain. Just when it looked like NVIDIA was building its empire behind closed doors, they dropped a bombshell. Groot N1, the AI brain behind their robotics platform, is now open source. This means any developer, researcher, or robotics company in the world can start building their own intelligent robots using the same tech as NVIDIA. It's a bold move, but it's also strategic. By open sourcing the core, NVIDIA ensures the world builds on their platform, just like Android did for smartphones. They're not just making robots, they're building the infrastructure for a robot-powered world. Imagine a future where every city, every company, and every home customizes its own robot assistant, built on NVIDIA's brain. The triple infrastructure play. In the final moments of the keynote, NVIDIA outlined their grand vision: 3 infrastructures. 1 future, cloud AI for powering the brains of the internet. Enterprise AI for transforming how businesses operate. Robotics AI for reshaping the physical world. Each layer connects to the other. Data collected in the real world is processed in the cloud. Models trained in the cloud are deployed into physical robots, and those robots send back even more data. It's a self-feeding loop of intelligence, a neural network for the planet. And NVIDIA is building every part of it. The competitors, who else is building the future? NVIDIA may be leading, but they're not alone. The race to dominate robotics has caught the attention of some major players, each with their own vision of the future. Tesla is developing its Optimus robot, a humanoid machine designed to handle repetitive tasks at home and in the workplace. Elon Musk claims it could eventually replace human labor in dangerous or boring jobs. And while the project is still early stage, Tesla's ability to scale and integrate robotics into its automotive factories gives it an edge. Boston Dynamics, famous for its viral robots like Spot and Atlas, focuses on agility and movement. Their robots can climb stairs, navigate rough terrain, and even dance. Backed by Hyundai, they're bringing advanced mobility to real-world applications, from security to logistics. Then there's Amazon, quietly embedding robots throughout its supply chain. Their robots may not be humanoid, but they're fast, efficient, and already working alongside humans at scale. Each of these companies brings something different to the table. Tesla brings ambition, Boston Dynamics brings mobility, and Amazon brings practical dominance. But NVIDIA brings intelligence. Their strength isn't in building the body, it's in building the brain that powers it. And in a future ruled by intelligent machines, the smartest brain may very well win. The quiet takeover is already underway. Most revolutions are loud, but not this one. NVIDIA isn't selling fear, they're selling capability. A smarter factory, a safer warehouse, a more efficient delivery system, but underneath all that, they're creating minds. Physical, autonomous, ever-learning minds that will one day run most of the world's infrastructure. And the scariest part, it's already happening. Every step is calculated. Every advancement builds on the last. This isn't chaos, it's strategy. So, what happens next? The rise of physical AI won't be dramatic. It won't be announced with a bang. It'll arrive slowly, silently, in the form of helpful machines solving practical problems. Until one day, we look around and realize they're everywhere. Robots won't take over the world like the movies show. They'll quietly become the world. The only question is, will you adapt or be left behind? And maybe, just maybe, the age of intelligent machines won't end in fire and war, but in collaboration, coexistence, and a new chapter of human potential.